Okay, Assalamualaikum and a very good afternoon. Today we are going to discuss few examples on Fourier transform properties. Okay, let's look at the first example. So given the Fourier transform for signal ft is as shown in figure Q1a, sketch the Fourier transform of new signal given by this equation and briefly discuss the process involved in the transformation process. So obviously we know that if you have a signal ft, so it will produce the Fourier transform, it will produce f omega. So in this case you have the f omega, but you don't know what is the ft. Next, you need to find or sketch the Fourier transform of new signal. Given a new signal fn, we call for a new signal t, meaning that you will produce fn omega. So now the fn is equal to e fn t equal to e j3t ft, in which it will produce fn omega. So what is the fn omega? So we need to check in the Fourier transform table. So what this equation will be in frequency domain. So let's check the table. So if you compare the given equation with the one in the table, that's basically a modulation process. So you can compare the given equation with the one you have. So it is ft ej 3t. So obviously this one will produce f omega minus your omega naught. So in this case, omega naught equal to 3. Okay, so now you know that the f and t equal to the given equation will produce fn and omega, in which it is equal to f omega minus 3. What is f omega? So f omega is the given signal. So meaning that you can transform the f omega, the original signal, into a new form fn omega by having the signal in frequency domain shifted to the right by 3. So fn new equal to f omega minus 3. So this is equal to f omega minus positive 3. So the signal will be shifted to the right by 3. So hence the final output looks like this. So the question asks you to sketch the Fourier transform of the signal. So you don't even need to get how the signal looks like in time domain. You just need to sketch the new signal in frequency domain. So the original signal being shifted to the right by 3. So don't forget to answer the second part of the question. Discuss the process involved. So in this case, you know that first, that's modulation process. When the ft function is multiplied with exponential function j3t. So secondly, what happened to the signal? You can see that original signal being shifted to the right by 3. And then what else? You can see that the signal, anything happening to the amplitude? No changes in the amplitude, so only in time. So I think that's what the two processes involved in the transformation process. Okay, let's look at the second example. So given a Fourier transform of signal xt equal to x omega given as the function shown, and we need to find the Fourier transform for the following signal. So we know that xt in time domain will produce x omega in frequency domain. So you need to find the Fourier transform for the following signals, meaning that you need to compare the given signal with the Fourier transform pairs or Fourier transform table in order to get the final output. Okay, given x omega as the Fourier transform of signal xt, so you need to find the Fourier transform for the new signal given by x minus t. So obviously you know that if you have xt, it will produce x omega. So now what is x minus t in frequency domain? So obviously you need to refer to Fourier transform pair or Fourier transform table. So if you have f minus t, so the signal in frequency domain will be having f minus omega. So obviously you will be having x minus omega. So you already have the x omega equation. So in this new equation, the omega will be given as negative. So you have the x omega. So in this case, what is your x omega? So x minus omega equal to, so all omega will be negative values. So it's negative omega squared plus j4 negative omega plus 2 divided by negative omega squared plus j4 negative omega plus 3. So now you can simplify the equation. So your x omega equal to omega squared minus j4 omega plus 2 divided by negative omega squared minus j4 omega plus 3. So this is the Fourier transform for x minus t. So x minus t will provide ft. Okay. Okay, next example 2b. So you need to try different xt equation. So a new equation given by x minus 2t plus 1. So obviously you need to compare with Fourier transform pairs. So you may notice that this equation is basically more or less equivalent to this shape. So you can compare directly the given signal with the one in the table. So given is x minus 2t plus 1. So you know that your a in this case equal to negative 2, and then your t naught equal to negative 1. Why negative 1? Because this is negative. So the t naught is, at the back is positive 1, so it's negative 1. So your t naught is negative 1. So this one will produce 1 over, your a is negative 2 modulus. So f, so in this case, in our case is x omega divided by a is negative 2, and then e negative j omega, your t naught again is negative 1 over a negative 2. Okay, so next, complete your equation. So what is x omega? X omega again, the given equation. So but in the new case, in the new signal, the all omega will be divided by negative 2. So now x negative 2t plus 1 will produce 1 over 2. So what is your x omega? X omega equal to, so omega, all omega must be divided by negative 2. So omega over negative 2 squared plus j4, again the omega must be divided by negative 2 plus 2 divided by negative omega divided by negative 2 squared plus j4 omega divided by negative 2 plus 3 n multiply with e negative j omega over 2. So then simplify the equation. So here you have 1 over 2 omega squared over 4 minus j 2 omega. So 2 and 2 plus 2 divided by negative omega squared over 4, then minus again j 2 omega plus 3 multiply with e minus j omega over 2. So you can simplify the equation further if you want, but please take note there's another omega here. So do you think that this omega needs to be divided by negative 2 or not? Okay, so you don't need to replace this omega by omega divided by minus 2 because this omega, the x omega, only affected by omega divided by minus 2. Okay, so this is the function when you have shifting. Okay, so there's no changes in this exponential function. So therefore, the x minus 2t plus 1, the Fourier transform is this equation. Okay, move on to the example 2c. So given a new equation, when you have a signal being convolved with the second signal. So again, you need to refer to Fourier transform pairs or Fourier transform table. So when you have convolution in time domain, so the Fourier transform of the signal is basically the multiplication of two signals in frequency domain. So let's have the equation. So you have your xt is equal to x1t convolve with x2t. So what is x1t? So your x1t is equal to xt, while x2t equal to 2 del t minus 2. So in this case, we know that x1t convolve with x2t will produce the Fourier transform is x1 omega multiply with x2 omega. So what is your x1 omega? So x1 omega equal to x omega, because x1t, so we know here is x1t equal to xt. Therefore, x1 omega equal to x omega. So you already have the x omega, okay, as given the given equation. So now you need to identify what is x2 omega. So x2 omega, so x2t given by 2 del t minus 2. So what is x2 omega? So when you refer to the table, so when you have the shifted impulse, so a delta t minus t naught, it will produce ae minus j omega naught t. So in here, you know that a del t minus t naught will produce a minus j omega t naught. So your equation 2 del t minus 2, meaning that it will produce the capital A equal to 2 e minus j omega. Your t naught is in this case positive 2. Okay, so your x2 omega equal to 2 e minus j omega 2. So now solve the convolution. So your x omega equal to x1 omega multiply with x2 omega. So what is x1 equal to x omega? So it is omega squared plus J for omega plus 2 divided by negative omega squared plus J for omega plus 3 multiply with x2 omega given by 2e minus j omega 2. Okay, so then you simplify the equation. So please simplify or solve the equation. Okay, with that, thank you.